Okay, so I guess let's start with 5. I don't think it really matters too much on the way we go, but a couple of you had reached out to me from my email regarding number 5. So let's start with that one. Wait, is this the right chapter? Is that right? Yeah, we had the nerds. Okay. All right, so we've got a revenue maximizing landowner. So let's start with that. I thought we were trying to maximize profits. So right away, this to me starts off with a little ringer here with revenue. Consider a revenue maximizing landowner that's got 24 hectares of vacant land to sell in a new subdivision. What do you think on that? What's your thoughts? A revenue maximizer. What might be true about a land developer in terms of their cost? Because I would still
the buying the land if they're developing.
Okay, so the cost of buying land is possibly a sunk cost, not necessarily because they could be, have a loan on it, but it would be fixed probably. So if they did borrow on the speculated land, they might have had an interest rate that they're just going to pay on. So it's not a variable cost. So when they throw revenue maximizing, I mean, I think that in this context, it's pretty consistent with our profit maximization of total revenue minus total cost. Because if your costs are fixed or sunk costs possibly, then maximizing revenue is really the same thing as maximizing profits. So I think that's maybe the first thing that jumped out on this one right away. Let me open up the chat box here. I didn't have it open. Oh, you got it. I got you, Nate. Okay. So upkeep for land. Good. I'm going to just put the chat box over on my other window over here. Okay. So the willingness to pay for land is big B for a high income person compared to little b for a low income person. The demand for land, lot size, is S for the high income person, big S and little s for the low income. The income of the high income household is 40% higher than the income of the low income household. And the income elasticity of demand is 1.5. So whenever we pull in income or elasticities, hopefully you are starting to have it in the back of your mind what those formulas are if you don't have it at the forefront, or you've got a resource to jump to right away. So the price elasticity of demand is percentage change in quantity demanded over the percentage change in price. And the income elasticity, we're just going to divide by the percentage change in income. So instead of price, we do the income for the income elasticity. So that's our general definition for that. And so we've got an income elasticity of 1.5, and the high income household is 40% higher income than the low income household. So what did you guys put here for this one? Does anybody want to volunteer their work for starters? I'm going to share. I was thinking you guys could actually share screen if you've got your Blackboard open. If you put up your homework to your particular problem, that would actually go faster than me having to do it. So if somebody would like to share what they did here on all the land in the subdivision, the answer key was what? Let's see, number 5. B is 60% larger than little b. Big B is greater than 60% larger than B. I guess that maybe that's kind of a weird way, but some of you guys figured this out. Who wants to share their work? Not everybody at one time. Slow down. We can't handle the volume of that. Give it a try feature here. All right, let's see where we'll just do some people at
I don't know
random.
how right it is, but I can try and pull mine up.
Okay, yeah, why don't you try and pull it up?
I'm looking at my Blackboard right now.
Good idea. I'm trying to get mine. And then I'll pull up, Luke was one of the ones on this too. So we'll have you share your screen. Daniel, when you get a chance. I think I have to stop the share, so let me know when you're ready, when you get yours pulled up.
It's loading into it right now, so hang on.
Okay.
Mod 5. Oh, shoot, wait, it's in mod 6, isn't it?
Yeah, chapter, yeah, I guess I don't know how you're loading it, but chapter 15, back of the chapter problems, if you, I don't know if you guys.
Yeah, okay, I got it right here.
Okay.
I don't know how to share screen, though.
Okay, so you have at the bottom of your screen, I'm going to stop my share. I don't know if I have to or not, but I probably do as moderator.
Oh, okay, I see the button.
But now the button, yeah, share screen.
Like this, maybe? Can you guys see that?
It's starting. It's trying. Yep, there we go. We got it.
Oh, cool. Okay, so it's page 3, so let it load. Okay. So, oh shoot, too far. All right, so this is what I had. I don't know how right it is, but for part A, I put all 24 hectares or whatever it is will be purchased by low-income households if B is less than 60% more. If big B is less than 60% more than little b, it's because the high income's demand for land won't be high enough, which is the big S compared to the little s, and the higher premium per unit of land would favor the low income.
Okay.
If that makes sense. That's what I had for A.
And that was so part A, all of that will be purchased by the low income if B is 60%. Where did you get the 60% piece from?
So I think it's part of the problem. How it says high income is 40% more than low income. So if you do 1 minus that, then you get 0.6, which is 60%. And so that's going to lead to what they need to have more than little b, so that they can buy more land than the little b, which would be the low income.
Right. So from a formula standpoint, you solve for the percentage change in quantity, which is the numerator for our elasticity formula. Is that right?
Yes.
Okay. Yeah, that sounds good. So questions on Daniel's, or did anybody do it a little bit differently? I don't think I'm able to. Let me see if I'm able to write on your screen. I probably.
Oh shoot, my bad.
Look, did you do that or did I do it? I
did that. Sorry.
Okay.
Do I need to bring it back?
No. Why don't you just leave it off for now?
Okay. All right. Sorry, I thought we were done.
So let me do a little whiteboard stuff here. So we have the income elasticity is equal to the percentage change in quantity over the of units over the percentage change in income, right? And so how this is usually talked about is that, hey, if you have if the income elasticity is 1.5, and that means our interpretation from above here is a let's call it a 10%. Remember how we can do that differently. A 10% increase in income leads to a what? Go to the chat box and help me out with finishing off my statement here that you guys should have memorized for the final and all your other tests. So if the income elasticity is 1.5, a 10% increase in income will lead to, you finish the sentence, ... Good. Lead to a 15% increase in quantity. Good, JC. Right? So with the 10 down here, and we know that it's 1.5, it must be a 15 up top. So 15 divided by 10 is the 1.5. And so that gives us a nice way to interpret that. So what's a little bit different here is that we're looking at low-income people versus high-income people, but the story can be kind of similar, right? We've got a low-income person and a high-income person, and then the problem gives us our amounts. Let me pull that back up here from the problem. Oops, I gotta do a screen share. So we've got enough information from the problem that the low income person, okay, I wasn't sure if I had my drawing tool on or not. So the income of the high income household is 40% higher. So that way we've got 1.5, income of 40. What does that number need to be here? It needs to be the 60. Okay, final questions on that one? All right. Suppose that B, big B, big S, little b, S follow this array. So those are the values, 160, S, 120, and 0.1. All of the land in the subdivision will be purchased by households. By who? Because why? So on this one, let's see, Luke, should we look at yours? You weren't sure about your answer or something?
I just put down what was in the book. I didn't know how to do it. So, I mean, you could look at mine, but it wouldn't have an answer on it. That's
okay.
not going to tell you anything.
So who wants to show kind of why or what they did here? Who's got something they're proud of? I think it's good for you guys to see other people's work and kind of how you did it. I know some of you guys work on it together. But all of you need to know this for the, for the test. We're going to have a similar type of problems. You might be given this problem right back. So now's your time. Who's up? Let's see. Daniel, go verbalize here for a second.
Man, again?
No, you're not on the hook. Give me a number between 7 and 13.
7.
7. 1, 2, 3, 4, 5, 6, 7. JC, you are up on the lucky random draw. So JC won the luck of the draw here.
I love you, JC.
Let's see. Sometimes I wish I could get this thing out of my way. There we go. All right, JC. Pumping iron to the brain. Good idea. Oh, your thing's not unmuting, huh? Okay. So let's see here. Is it on this one? No. All right, so B. All right, so JC, you're still not able to unmute. You can maybe do a little chat box if you can't figure out. I bet maybe your microphone setting is weird if you go to your settings in the lower left-hand corner. But so low income because they have higher. Your part B says low income because they have a higher premium per unit of land. Big B over H equals 10 versus 12. Okay, so what does that mean? Maybe you should all take a stab at this, even if it's a guess. Don't worry about it. Let's go to the chat box and tell me what you think. So that's basically the answer key answer, which isn't going to help you much on the test if that's all you were able to do was regurgitate. So what does low income households B over H equals 10 compared to B over H equals 12? Think about those components. So JC, no, we can't hear you yet if you're asking a question by your thing there, if you're trying to verbalize. So B over H equals 10, low income because they have a higher premium. That idea of the premium is important in the next chapter coming up too. So we do want to be aware of what that means. And so here's the problem again. So B over H versus little h. Okay, Luke, the willingness to pay for land is higher per hectare. Yeah, that is definitely the direction they're heading with that ratio. I mean, what is that ratio? Little h and big H. What are they taking the ratio of to get that? We got that big B is 160, and the answer is 10 to the ratio. So just doing a little quick and dirty math here. If B is 60 and the answer key told us it's 10, so it's 160 equals 10. So last time I checked, that must mean that that's 16. And does that help us crack the code here? Whereas we've got the little h equal to 12. Again, that's from the answer key. So doing a little backdoor work here, we got B of 120. So 120 equals 12. So in order to get a 12 there, that must have been a 10. So what is the H part? Big H and little h. All right, the size and the land. Okay, where did you get that from? So hopefully you guys have little pencil sketches here. So we got H stands for hectare. Okay, so we got the per hectare. Is that what you're getting at? So it was a tenth. Willingness to pay per hectare. So how do you get the number, JC? And Luke, you've got willingness to pay per hectare for each income. So my question is, how did we get the H's to begin with? So the answer key just kind of throws out willingness to pay per hectare. Is that how many hectares, or? Do we have to use part A for this or not? So yeah, it is willingness to pay for sure, right? So to Luke's point, we've got 160 is the willingness to pay. So big B is the willingness to pay for land.
Do we have to use the price elasticity in this at all?
Well, we don't have a price elasticity, but we
sorry,
have,
the elasticity of demand. I mean, sorry.
yeah, we've got we've got an income elasticity. That's what I kind of want to think here. Where is that coming from? Because we got two different numbers down here at the bottom. So 160 and 120 is the willingness to pay. And little s, the demand for land, the lot size is S. So that would be like the fraction of the acreage. If we're talking lot size compared to S for the smaller guys. So if we have 0.1, and we know that there's 24 hectares of land total.
The demand for, so the higher income people are going to want a bigger piece of land. And
Yeah.
so the lower income people are going to be able to outbid them because they don't want as much land.
Yes. So that's definitely what it's getting at. So have you cracked the code on what the 16 and the 10 are? The H and the big H, the big H and the little h. And notice that the S here is left as a variable, right? So they didn't tell you that.
The 16 and the 10 should be the, like Luke said earlier, the willingness to pay, right, per each hectare of land, but it's going to vary because the because like for each of the for like the low income, they're going to want less land, like Luke said. So it's going to vary, and it's going to be a different number because they're not going to buy as much, and the higher income is going to buy more. Is that right?
Yeah, I mean, that's definitely what we're looking for. I just want somebody to kind of tell me how this is mathing out. So all of the land will be purchased by somebody because why? Where did the answer key gives us an answer of big B over big H, 10, and big B. But if we pretend we don't have the answer key, I'm wondering how they came up with that. We know that it's 160. That's given in the problem for the over here for the, this is the high income people. and this is the low income people. 120 is given to us. So where does the 10 come from?
Is that the amount of land that they're purchasing?
Well, we know that little s for the low income people is that. So little s is 0.1 is the demand for lot size. So that's 0.1 of a hectare, by the way, right? So S is in per or lot size for the low income people. We've got our income elasticity. Would that help us out at all if we've got the 1.5 and then we got the low income people and the high income people? So we had a 40% higher household income. So an increase in income of 40% led to a percent change in quantity of 60, right? So 60 over 40. So that was the percentage change in quantity demanded over the percentage change in income. So these people bought or have a 60% higher lot value. So this is the change in quantity from when you're a low income person. So what do you think that would be? We know that low income people, the author gave it to us right here, right? What's the lot size? 0.1. So 0.1 of a hectare is the low income person. And how much bigger of a lot do high income people want to buy? Go to the chat box for that.
60% bigger?
60% bigger. So how could we do that? Why don't we chat box that one? If you guys want to tell me, how would we look at the lot size of the high income person? How would you put that into a formula? Just kind of show your work. I mean, you could show the answer right away if you want to. Hopefully you got a calculator handy. .1 times, not 0.6, 1.6. Good. Yeah. So Daniel, the formula that we use for adding on is 1 plus, kind of like 1 plus the interest rate. So it's 1 plus the rate, which is 60%, which is 1 plus 0.6 gives us what? What is the size of our high income? 0.16. So now they're having 0.16 of a hectare is their demand. All right. So our B over H thing here ends up looking at their sizes of lots that they have. Okay.
So do we just take those numbers out of the decimal? So the 0.1 turns into a whole number of 10?
I think that's kind of an abbreviation by the answer key, because if you convert it back, it still would be per hectare. So it's our big maximum willing to pay was S. Our big S was 160. So let's see, where are we? Gosh, I've got so much scribbles on here. I can't even read where we were. Yeah, so the willingness to pay for the high income person is 160. So it's 160 per what. And so they must have either did a conversion or not. But if we just did 160 divided by 0.16,
you get like 25 or something.
What do we get there? If you want to chat box that, you guys, 160 divided by our 0.16 gives us the $1,000. So they shifted some decimal places over. I'm kind of thinking that the answer key here, it's kind of 6 of one, half dozen the other, but really it's more pure that this is $1,000 is the price. And then we can think about per what. So this is 0.16 of a hectare, and this is $160 per hectare. So if we flip over the numerator, multiply it, we've got $1,000, right? So that's our price. So, and the same thing here, we're going to have a couple zeros added on, so we'd have 1,200. So at the end of the day, the amount per hectare, as JC was pointing out, was the right interpretation of what we're ultimately dividing it by. So, but these were smaller than the sizes were that way. Okay, before I erase this masterpiece, I hope you guys will present your stuff better than the way that looks like. Don't let your homework look like this, but we kind of tell the story as we talk. 10-second pause for questions before I erase, or while I erase, I guess, if somebody wants to unmute. All right, away she goes. So part C, suppose the city's objective is to exclude low-income households from the subdivision, which is part of our upcoming chapter as well. The city will succeed if the minimum lot size is at least what? So if we're trying to exclude low-income households, how can we keep out the poor? So the answer key here was 0.12.
Really, I was thinking though, just make the hectare size bigger than the 0.10. That's where they're.
Yeah, but as you change it, that could change. That was just the equilibrium amount.
It has to be 60% greater than the little b.
Okay. Yeah, so that's where the math is going to come in. So did you do that on your paper, Daniel?
Yes, to an extent.
Can you easily share it? You want to share your work again?
Yeah, I can go back to it, but I mean, so what I wrote on my paper is kind of confusing.
Or if you want to write in the chat box, if you can. I'd like to show, I can try to get back to your work as well.
I already got it pulled up here still. It works. Okay.
Yeah, so kind of that high income, low income topic is going to be the place where we go back to with the other. I can probably get it fairly fast here. All right. While we're waiting, other questions, and we might kind of move on from that one anyway, but here, I'm going to pull it up real quick, but so we still got some time to load a few more.
It's the third page once it loads.
Okay.
So basically, the minimum lot size, like the answer key said, has to be the 0.12. I realized after I submitted it that my math is wrong there.
Yeah.
Yes, but basically, so based on like the last problem, part B, where that we saw at the beginning whenever we were doing the equation to get the 60%, or I think it was part A actually that you did that.
Yeah.
With the 1 minus 0.6, or sorry, 1 minus 0.4 gives us the 0.6, which is where the 60% comes from. So if big B is willingness to pay is 60% greater than little b, then the big B is going to outbid.
Yeah.
And the minimum lot size, based on part B, the minimum lot size has to be at least 0.12 because the low income wants it to be 0.10. And if it is, then they'll always outbid. But if it's greater than that, then the high income is going to outbid the low income.
Yeah, as long as we can keep, basically in general, as long as we can keep that lot size big enough that the high income people will still be buying it, then we will effectively keep the low income people out, which, by the way, goes on in the real world. So that is a possibility. All right, let's take a peek at this number 3, the nerd neighborhood. So it's important for you guys to kind of get what's going on with this premium curve. And so we had kind of an unusual function, which is what these problems usually throw at us. So we had a n squared and an n. And Luke, this was one of yours that you had, right? So let me see what you did on your picture. Because if I remember right, because I was in the middle of trying to see if we could look at this last time, if I remember right. So Luke. Yeah. Okay, so what's going on with your picture here? You were using the square root function?
I was trying to, so each curve was supposed to be the different function. So the square root one was one of them, and then the 8 times n was the other one.
Okay.
I don't know if that's correct, but that's pretty much what I did. So for the first one, we have 0 houses, 12 households in the neighborhood. At the very top of the graph would be 144 for the n squared, and then the 8 times n, it would be 96. And so basically I just plotted where they'd be, because I think how the question was framed.
Okay, so let's kind of look at your horizontal axis here. What are you measuring? This is the part that with these graphs.
Yeah, I was measuring the number of households.
Okay, number of what households?
So the first point in the far left, that's 66. So that's that was the perfect integration.
Okay.
And then the middle point, that's the mixed equilibrium.
So it's the nerd neighborhood that is the preferred one, right? So as we move this way, we have 7 nerds and 5 of the other, correct?
Yeah.
Okay. So and I'm kind of using this as an illustration just to think about what each situation would mean. The scale starts off at perfect integration versus perfect segregation, where over here we'd have all the nerds in one neighborhood and none in the other. Okay, so let's go back to the problem. On the answer key, what did we have? Stable, and then the mixed was the solution. So this was a stable outcome. Let me get this back. Oops, sorry. Okay, so perfect integrations, stable, not stable. Is it in equilibrium? Is it not? Illustrate. Okay, so we've got the 12 households. Bid premium for non and otherwise we got 8 and 8. So if we have each neighborhood accommodates 12 households. So when we look at that, if we have each neighborhood, what's the total amount of the city? Go to your chat boxes. So each neighborhood accommodates 12 households. So People in your city prefer to live close to nerds. The bid premium for the nerd is that. Non-nerd is 8. So how many people are in the city? Big B. Luke, I don't know if that looked like it was almost from the old problem, but where did you get that? I was just looking at the number of households. So each neighborhood accommodates 12 households. So in this two-city model, what I'm trying to think about is what is the amount we're going out here. So this is 12, and this is the nerd side. So if we're here at this point, we've got the perfect integration, right? Where this is number of nerds. Yeah, so 24 is what I was looking for. So it's 24 in each neighborhood. So what we're looking to say is the current mix of people in equilibrium or not? And so with the n squared business, so n is the number of nerds in, number of nerd households in the neighborhood. So if this is at, if this is at 12, if we've got 12 nerds or if we have 0 nerds is kind of our starting point. So what is it at 12 nerds versus this function? So the non-nerd households, the bid premium, so non-nerds want to live in nerd areas too, nerd neighborhoods, and it's 8n. So if I go over 1, I'm going to go up 8. Over 2, up 16. So we're going to have a nerd, non-nerd bid or premium curve that is a straight line, right? So that is actually slope-intercept form where the intercept is 0 for the non-nerd households. And then we've got the nerd function as the n squared. So 1 times 1 at 1, this is for the non-nerds now, 1 squared is 1. 2 squared is 4. 3 squared is 9, right? So let me draw a different graph. We've got a non-function that's going to be going up like this. And so at what level do they equal each other? Go to the chat box. At what level would they equal each other? Clear this. Good, 64. So now that you got the gist of it, we have a straight line, that's the non-nerd premium curve. This is the premium that they're willing to pay to live in a nerd neighborhood. So this is number of nerds, and this is 12. And so at 8, 8 squared is 64. And rise over run down 64. The rise over run of this straight line is also 64 at 8, right? Over 8, up 8 times 8 is 64. And so our nerd premium curve looks something like this. And so the question is, is that a stable equilibrium or not? And this is where we get into understanding the model in terms of segregation or mixed. And so if we start at the integrated equilibrium, where it's equal nerds and non-nerds, is that a Nash equilibrium at 0, 0? Well, at 0, 0, there's not a premium either way, right? Because 0 squared is 0, and n at 0, 8 times 0 is 0. So they're actually touching right here at the intercept. So that is a Nash equilibrium. But what this is bringing up is it a stable equilibrium? And so if there's any deviation, even though it's a Nash equilibrium, which means nobody has incentive to change, but this idea of stability is kind of a dynamic approach to thinking about these problems. And so if we take one step away, maybe even 2 steps away, let's go to 2. At 2 nerds, remember this is number of nerds in the neighborhood mix. If there's more nerds, the non-nerds are willing to pay more than the nerds. And so what's going to happen in terms of movement? Are we going to go to having more nerds or non-nerds? So if there's non-nerds in there, then they're going to be the ones bidding up. And so which direction are they going to head when we have more non-nerds? Are we going to be going, and I want to go to the chat box on this. I know this is a little bit confusing, but starting from this point, are we going to move this way or this way is kind of the question. To the left or to the right? Are we going to move back towards the integrated equilibrium or away from it if we started at 2? So in the chat box, let's put left or right. Basically, are we going to head to having more nerds, maybe heading towards complete segregation, or are we going to go backwards? Who's going to be bidding?
Hey, it's 2:52, by the way.
Oh, thank you, Kyle. I'll keep talking. You guys can drop off if you have to go. You can think of this as office hours now. So left or right? Who's going to be, got a question mark to the right. So let me phrase it differently. Who's willing to pay more to live in the neighborhood? A non-nerd or a nerd? Remember, the non-nerd line is the blue one. The nerd line is the orange one. So that's the nerd line. Who's willing to pay? Non-nerds. So now if a non-nerd moves into this neighborhood, are there going to be more nerds in it or less nerds? Put that in the chat box. Less, good. So we're actually going to be moving to the left. So this point here of 2 is not stable because the non-nerds are going to outbid the nerds, and we're going to move back to perfect integration. So that's perfect integration. And so that's why your answer key says that this is a stable equilibrium. Does that make sense for everybody? I see a big O from Daniel. Good. Do I have a couple more O's? Whoever's got that aha moment, maybe give me some love in the chat box, or if you have a question, then make sure you have that as well. Oh, good. A big yup from Liz. Okay, thank you. Wow, RustyCon rocks. Okay, love it. Love it. Gives me more energy for doing this stuff. Okay, so I think we can leave it at that. That was a pretty intense look at what we're doing. And so then you can go back and study these. So once we get into nerds being willing to pay, this is what's kind of weird about this problem. And I don't know if this is where I can't remember if this is where the question goes. But if we get to a point where we're at 8 and we head this direction, so now we've got 9 nerds in a neighborhood. Now check it out. Now we're going to move towards segregation. So now all of a sudden nerds are going to outbid the non-nerds. And so now we're going to move to this, and this would also end up being a stable equilibrium. All right, that looks like a good place to stop.